So this is actually test number 2 review, but it's chapter 1. So this is just kind of a simple, straightforward review, but also make sure you review the notes, homeworks, and all the examples there, and the quiz too, to help you review. So let's look at A. We want to find the domain, range, and intervals of increasing, decreasing, and constant. I'm going to say that this one's a closed circle and this one's a arrow, just to change it up a little bit. So what we do with this one may be different than the answer from the answer key, because I made one a closed circle and one an arrow, but we can do it. So let's start with the domain. Domain is our x values going from left to right. What would our domain be here? Awesome. Bracket or parentheses at 5? Bracket, -5 to infinity. Perfect. Next, our range. Our range is the y values. What would our range be? -4. That one has an arrow, so it's going to infinity. And 4 gets a parentheses because it's an open circle. Now let's talk about our intervals of increasing, decreasing, and constant. So we read a graph going from left to right. If I was standing on the far left side of my graph, bless you, would I be walking uphill or downhill? Downhill. We'd be walking downhill from where to where? -5 to 1. Perfect. Bracket or parentheses? Parentheses. Increasing, decreasing, and constant are always parentheses. And always x values. So we're decreasing from -5 to 1. And then at 1 down here, we start walking uphill. So we're increasing from where to where? From 1 to infinity. Perfect. Are we constant anywhere? No. So looking at B, we're going to graph one piece at a time. So starting with the first piece, what number would I plug in first? -2. So we always start with the numbers that it gives us. So we're going to plug in -2. When we plug in -2, this would be 3 minus 2, which would be 1. Do I have an open or closed circle here? Open circle. So we're going to go to the left to -2 and up 1 and put an open circle. Now we're talking about x values that are less than -2. So what would we plug in next? -3, sure. So 3 minus 3. We plugged in -3 and we got 0. So the second point just gives us direction. So it's not also an open circle. It's just the direction of the graph. So we're going to go to the left to -3 and stay at 0. So our graph goes this way. Now let's move on to our second piece. What number would we plug in first here? So we start with the numbers that it gives us. So I'm going to plug in -2 and 2. So we're going to start with the numbers that it's giving us. So -2 squared plus 1 would be 5. So when we plug in -2, we get 5. Is this an open or closed circle? Open, because it's just less than. So we go to the left -2, up 5, and we put an open circle. Now let's plug in 2. So 2 squared plus 1 is also 5. So we plugged in 2 and got 5. Is this an open or closed circle? It's a closed circle. So we're going to go to the right 2, up 5, put a closed circle. Now, what type of shape is this piece of our graph going to have? A parabola shape. So I can't just connect my 2 points with a straight line because I know that it's a parabola, so it's got some type of curve to it. So what else could I plug in to see how my graph goes? 0. Let's plug in something in between -2 and 2. So plug in 0. So 0 squared plus 1 would be 0. Would be 1. So our point would be 0, 1. Now this piece just gives us the shape of the graph. So it's not an open or closed circle. It's just giving us the shape. So we're going to stay at 0, go up 1, put a point there, and then connect our points. If you want to plug in more points, you can to get a more exact shape. That's totally fine. Plug in as many points as you want. But with a parabola, you're going to need at least 3 points to see your shape. With a line, you only need 2 points to draw a straight line. Now let's graph our third piece. So here we have an absolute value. What shape does an absolute value graph have? Absolute value has a V-shaped graph. But keep in mind, depending on where we are, like which chunk of graph we're looking at, what piece, we could have a V-shaped piece, or you could have kind of a straight line piece if you're just looking at like the arm of your V-shaped graph. So just keep that in mind when you're plotting points. Let's plug in a couple points here so we know the shape. So first, we're going to plug in 3. Always start with the number it gives us. So negative absolute value of 3 would be -3. So 3, -3. Is this an open or closed circle? Open circle. So we're going to write 3, down 3, open circle. What should we plug in next? Anything greater than 3, so let's plug in 4. So negative absolute value 4 would just be -4. Now this point just gives us direction, so it's not also an open circle, it's just direction. So we're going to write 4, down 4, put a point. You can plug in 5, 6, 7, 8, whatever you want. It ends up being just kind of like the arm of that absolute value graph, so it's not a V shape, it's just a straight line here. The other part that we erased is the V shape. It would look like this if we had the rest of the graph. But we're only talking about where x is greater than 3, so it doesn't include that V shape. And let's find the domain here. What would our domain be? -∞ to -2. -2 is an open circle, so it's just a parentheses. And then what? -2 to +2, and then 3 to infinity. And +2 would actually get a bracket here because it's a closed circle. And then let's talk about our range. What would our range be? Awesome. -∞ to 5. Would 5 get a bracket or parentheses? A bracket, because it's including 5 because one of the points is a closed circle. All right, on the next page, let's look at number 4. It says find the following given that f of x is 7x minus 6 and g is 4 minus x. So first thing it wants us to find, I'm going to skip to b. Let's find f minus g. So f of x would be 7x minus 6 minus g of x. So since we're subtracting multiple terms, I'm going to put it in parentheses. So minus 4 minus x. Always simplify these. Simplify if you can. So for all of your combinations you want to simplify. What would we do here to simplify? Distribute the negative. So it becomes minus 4 plus x, and then we can combine our like terms. So 7x plus x would be 8x. Negative 6 minus 4 would be minus 10. And then to find f minus g of 0, we can plug 0 into the x. So that would just give us negative 10. Or if you wanted to, you could find them separately. Plug in 0 into the x here, 0 into the x for g. Get your answers and then just subtract them. So you could either find f minus g of x and then plug in the number it tells you, or plug in the number it tells you and then subtract them. Any questions here? All right, let's do C. So here we have f times g. So f is 7x minus 6 times g is 4 minus x. How would we simplify this? FOIL. So we need to FOIL. So 7x times 4 would be 28x. 7x times negative x would be negative 7x squared minus 24 plus 6x. Combine our like terms and put it in standard form. So negative 7x squared, 28x plus 6x would be 34x minus 24. So this would be f times g. All right, let's look at 5 down below. So let's find d and e. We want to find f divided by g of x. So I'm going to take my function f, which is x squared plus 3, and divide it by g, which is the square root of 7 minus x. Can we simplify here? So we can't simplify here, so we just leave it. But let's find the domain. When we have domain of a combination function, we have to check for 3 things. Domain of the f, domain of g, and domain of the new function. So let's go back to f and g. What is our domain for f? All real numbers. Be from negative infinity to positive infinity. There's no square roots here, there's no fractions, it's just all real numbers. So if I put that on a number line, it'd be all real numbers, the whole thing. Now let's talk about our domain for g. What's our domain for g? How do we find the domain? Set whatever's under our square root greater than or equal to 0. So 7 minus x is greater than or equal to 0. We'd add x. So 7 is greater than or equal to x. So if we rewrote that, we'd say x is less than or equal to 7. So we're talking about numbers that are less than 7. So on my number line, I'll put a 7 here. It's greater than or equal to, so it'd be a closed circle. We're talking about numbers less than 7. Bless you. Now our new function is this f divided by g here. What do we have to check in our domain here? What could we not have? What in addition to what we already have can we not have? Awesome. Under our square root can't be a negative, and since it's in the denominator of a fraction, it can't be equal to 0. So we'd set whatever is under the square root just greater than 0. So here we have 7 is greater than x, or x is less than 7. So this would actually just be an open circle. So we care about the domain that overlaps between our 3 domains that we have here. What overlaps? So from negative infinity to 7 with a bracket or parentheses? Parentheses. So that would be our domain of the function. The g up here in g. I just wrote it up top since we have more space up there. But since it was just a square root, we just set whatever's under the square root greater than or equal to 0. But if it's in the denominator of a fraction, it can't be equal to 0. All right, let's do e. So first let's find f of g of x. So what's on the inside here? G of x. So g of x is going to go inside f of x. So we have the square root of 7 minus x squared plus 3. Let's simplify. What simplifies here? The square root and the squared will cancel. So 7 minus x plus 3. And then we can combine our like terms. So this would be 10 minus x. So f of g of x is 10 minus x. Now let's find our domain. Now when we have a domain of a composition function, so when you're composing one function into the other, we only have to check for 2 things. Do you remember what those 2 things are? What do we have to check for to find the domain? The inside and the whole new function. And it's what overlaps between these 2 functions. So notice the difference of d and e. For f divided by g, we had a combination function. So we have to check for 3 things. When you have a composition function, when one function's going inside the other, you only have to check for 2 things, the inside and the new function. So let's check the inside. Which one was on the inside? G of x. We already found our domain for g of x. What was it? X is less than 7. Perfect. Less than or equal to 7. So if we put that on a number line, we'd have less than or equal to 7. Now let's find the domain of our new function. So our new function was 10 minus x. What's our domain here? All real numbers. There's no square roots, there's no fractions, so it's all real numbers. So on a number line, that'd be everything. So what overlaps between these 2 domains? Awesome. Negative infinity to 7. Bracket or parentheses? Bracket. Yeah, so when you have any of your operations, yeah, so you want to check for the 3 things. If you have f plus g, f times g, f minus, f divided by g, any of your math operations, you use this one. When you're putting one inside of the other, so if you have f of g or g of f, you'd use just the 2. All right, let's look at the next page. For A, f of g is the same thing as saying f of g of x. It can be written either way. Which one's on the inside here? G. So if it's written the first way, the second function is what goes on the inside. So g of x is going to go inside of f of x. So we have the cubed root of x cubed plus 1 minus 1. How could we simplify here? Awesome. 1 and minus 1 cancels. So I have the cubed root of x cubed. Anything else cancels? Cubed root and cubed cancels. So what are we left with? X. So again, when you are finding your combination functions or composition functions, always simplify as much as you can. Make sure you're doing the correct steps algebraically to simplify, but simplify as much as you can. All right, let's go to the next page. So for number 8, we want to find the inverse. What's the first step we need to do to find the inverse? Switch x and y. So f of x is going to become x, and x becomes y. What do we do next? We're going to solve for y, so let's subtract 2. So x minus 2 is equal to y cubed. Then what? Take the cubed root of both sides to cancel out with that cubed. So we have y equals the cubed root of x minus 2. What else? Are we done? What's the last step we have to do in finding the inverse? We got to put the little inverse symbol. So you could either leave it on the y, or if you wanted to change it back to f of x, you'd put f negative 1 of x. But you can leave it as y, just make sure you put the little negative 1 symbol, that inverse symbol on it. So this would be our inverse. So with the inverse questions, don't forget to name it. All right, what about for 9? What would we do here? Let's think about it though. Does it have an inverse? What's the one rule that we look for? X squared. Anything that's x squared has no inverse. If it's x squared, it does not pass the horizontal line test. So it has no inverse. So even though that x squared is under the square root, there's no inverse here. Whenever you see x squared, no inverse. Don't do the math. Don't waste your time looking for the inverse. There is none. So if we had the absolute value, there is like no inverse to the absolute value. Let's say if I had f of x equals the absolute value of x, and we were trying to undo everything here. How do you undo an absolute value? You can't. So this would also have no inverse. And think about it, the graph of an absolute value is a V shape. So this also does not pass the horizontal line test. So these would be the two cases. All right, for 11, I kind of changed the directions a little bit just so we can practice some different things, but let's find the zeros for A. So when it says find the zeros, we just change f of x to be 0, and we solve. How would we solve here? Awesome, we want to factor. So since our leading coefficient's not 1, we're going to multiply 2 times negative 30. We get negative 60. What are two factors of negative 60 that add to negative 7? Perfect. 12 and 5, and it's negative 12. Awesome. So x minus 12 and x plus 5. What do we have to remember to do? Awesome. If we start by multiplying, we have to divide by the leading coefficient. Simplify if you can, so x minus 6. If you can't simplify, move it in front. So this would be 2x plus 5. What's next? Set them both equal to 0, so x equals 6 and x equals negative 5 over 2. How would we find the zeros if we had something that had 4 terms? How do we factor something with 4 terms? Grouping. All right, and then let's do B and let's find the domain. We can find the zeros here. How would we find the zeros for this? How would we find the zeros? What do we do to find the zeros if we have a fraction? Just set the numerator equal to 0. So our zeros would be x equals 4. But let's find the domain. What do we have to look for when finding the domain with a fraction? What do we have to be careful? What can we not have in a fraction? 0 where? And the denominator. Our denominator cannot be equal to 0. So we'd solve, we get 9x squared cannot equal 4, divided by 9. X squared does not equal 4 over 9. Take the square root. So what does x not equal? Just 2 over 3? Plus or minus 2 over 3. How would we write that in interval notation? So if I put it on a number line, x could be anything except negative 2 over 3 and positive 2 over 3. So how would we write that? Negative infinity to negative 2 over 3 with a u. Negative 2 over 3 to 2 over 3. And 2 over 3 to infinity. Awesome. Perfect. All right, and then just for extra practice for C, what would we have to do to find the domain here? Set whatever is under our square root greater than or equal to 0. Perfect. So x is greater than or equal to 1/2. So this would be 1/2 to infinity. All right, I added a couple questions, so these aren't on your review, but just for practice for our test. So I'll call it number 12. Is this a function? So is A a function? Yes or no? Why not? What makes it not a function? The y squared. So if you had y squared or y to the 4th power or y to the 6th power, these are not functions. What about y to the 3rd power? Can y to the 3rd power be a function? Yes. And then what about b? Why is it not a function? Because the absolute value. Y can't be in an absolute value. Yes, but when y is an absolute value, it's actually a sideways v, which does not pass the vertical line test. So for determining if it's a function or not, we have the vertical line test. To determine if you can take the inverse or not, it's the horizontal line test. What if I had y equals the absolute value of x? Is this a function? What shape is an absolute value graph? It's a V shape. Does a V-shaped graph pass the vertical line test? Yes. So absolute value of x, yes, this is a function. But the absolute value of y, no, not a function. All right, for 13, let's talk about our transformations. So for the first one, when we subtract 4 on the inside, what does that do to our graph? It goes to the right 4. Awesome. And what about when we subtract 10 on the outside? Down 10. If we were to graph this, what does an x squared graph look like? A parabola. So it'd be a parabola that gets shifted to the right 4 and down 10. So that'd be what our graph looks like. Let's do the second one here. What does a negative on the outside do to our graph? It's a reflection where? On the x-axis. This is a reflection on the x. And then when we add 1 on the inside, which way does that move our graph? To the left one. So if I were to graph this, we shift our graph to the left one. And then we have a reflection on the x-axis. So again, it's an x squared, so it'd be a parabola. But a reflection on the x-axis means our parabola opens down. So it'd look like this. All right, last one, number 14. So we talked about this in the notes. This is our step integer. What do these kind of double brackets mean? What if I had double brackets of 1.2? What would this be? It's the greatest integer that is less than. So this would be 1. What if I had, let's say, negative, we'll do negative 1.2. What would this be? Negative 2. So again, it's the greatest integer that is less than. Always has to be less than the number in your brackets. What if I had, let's say, 4/3? What would this be? 1. Awesome. What if, let's make it more challenging. Let's say f of x equals what if we have this? And let's say we'll do f of x equals 0.5. Or x equals 0.5, sorry. X equals 0.5. So we'd plug the 0.5 in. So what's our greatest integer of 0.5? 0. And 0 minus 1? Negative 1. So f of 0.5 here would be negative 1. So if you have more math going on, just like your order of operations, PEMDAS, do what's inside the brackets first. So it kind of acts as parentheses. And then just follow PEMDAS from there. The right side has the open circle. So if we were to graph it, let's just say it was just x. So let's plug in, if we plugged in 0, what would it be? 0. So our first point would be 0, 0. If we plugged in 0.5, what would our y be? 0 also. If we plugged in 0.9, what would it be? 0. But if we plugged in 1, what would it be? 1. So it would jump to 1. So here we'd have an open circle at 1. Because it's everything that goes up to 1, but it doesn't include 1. So we can include 0.99999 because 0.99999 would bump down to 0. And then if we plugged in 1.1, what would our y be? 1. If we plugged in 1.9, what would our y be? 1. But if we plugged in 2, what's our y? 2. So we'd have an open circle at 2, 1, because it can include everything up to 2, but once we get to 2, it jumps up to that next step. And then if we had, let's say, like a -1 outside, what would that -1 do to our graph? Shifts it which way? And move it down 1. So all of our steps, if we started off with these red steps that we have here, they just get shifted down 1. So it keeps the same shape, but we just shift each step down 1. So if you have a transformation, I would say just make sure you understand the original graph, and then you can just apply your transformation from there.